G'day everyone and welcome back to the channel. I've just got a small little update video here for you. I was going to do some work on the RF amp tonight since I'm finished playing with that battery box for now. I've had really bad tooth pain on and off the last couple of days and it's come back this afternoon. I've been in searing pain for the past few hours and right now I can just talk. So what I have been doing is I got another nibbling tool. Well, I actually bought two of them in case I broke one, but I didn't, so I've still got two. Fitted the panel screen, got rid of the rest of the Motorola there, started doing a soak test. That's been running like that for about 4 hours. So I'm happy about that. That's at 4 amps. Oh yeah, you can see that. I wasn't sure if the screen focused. So what I'm going to do is I'm going to slowly move down in voltage and up in current and take notes of everything. I've just got to keep, checking the temperature of the transformer's like fairly warm. It's actually wonderful. It's literally just warm. Certainly not hot at all. The heatsink, yeah, warm. I'm more than impressed at the moment. I might not leave that there at the moment because it's got batteries in it and I don't want it sitting on something warm. Yeah, also, check this out. If I turn this is at 18 volts. Remember when I was building this, we were struggling getting 2-3 amps out of it at 18 volts. Well, I'll turn the load off and you watch the display on the power supply. That's 4 amps at 18 volts. So it's only losing about 15 millivolts or something like that. It's doing wonderful. And that is actually what's happening. I can stick some leads in here. One moment. You're going to see a bit of drop through the terminals here, but 18.147. I'll turn the load off. Okay, yeah, you see more drop on the terminals. I can prove that actually if I take these out a bit. Undo these screws actually. Put them back in. If I get these right at the output before what's getting dropped on that, 18.183, 18.186, you see, and I'll turn the load on. So there you go. It's actually performing really, really well. That's as high as it goes, 18.2 volts basically. So yeah, like I said, I'm going to continue doing the soak test. I'm basically just going to go down to like, I don't know, 16 volts. And we'll do 3 amps for a bit. And I'll just keep checking on the temperatures. What I'm going to do is basically just do this soak test. And where the Motorola badge used to be, next to the panel meter here, I'm just going to write I'm going to make up a little label that basically says what currents you can pull out at what voltages, just so I don't ever, not use it for a month or two, come back and use it and then try and pull, say, 8 amps out at 6 volts and cook the series pass elements. But I will say this will be really handy for sort of transient loads like testing amplifiers. Obviously only a small single rail device, but anything that's sort of transient, you could run this at a lower voltage and pull high current out of it that's pulsed, just not continuous. It'll handle that well because, you know, it's got two N3055 pass elements. It can handle a ton of power. It's just it doesn't have the thermal dissipation in terms of the heatsink. The transformer seems to be better than what do you call it? Well, actually, I haven't run 8 amps out of it yet, so I'll let you know. But yeah, you know, it's good. I'm happy. Like I said, it doesn't have the thermal dissipation, but other than that, it's quite handy. And don't forget, this used to be a device that had a red LED on the front, a little connector that was for a proprietary plug, and that was it. Not even a power switch. Fixed 13.8 volts, that was it. Now, you've got a power supply that goes down to 5.7, 5.8, and all the way up to 18.2. You know, I really can't complain about that. I've got banana jacks on the front of it. I can screw wires into them. I can put bananas in the front of them. You know, there's a ground lug there. It's got really low noise output now. It's got a power switch on it. It's got a screen. You know, I'm more than happy. I've taken something that was just collecting dust and made it useful. So I'll you know, in one of my videos, I'll make a little update video when I've finished doing the soak test and I know exactly what all the different currents at different voltages are, and I've made the label up, and I'll show you guys what we can get out of it. But yeah, for now that's that, and that's that for now. Like I said, I've got to order a different regulator because the one in there is dodgy, the -5 volt regulator, but we'll do that. That's all good. Well, I've actually got some coming, so just gotta wait for them. Yeah, that's really all I've got for you. Just a small little update. I just wanted to show that. I do have something else I'm working on too. I'll just show you. I've just got to set up all the software. I've installed the drivers, but I finally got one of these. So my 34401A can plug into the computer. So when I've got Ian Scott Johnson's WinGPIB, and I've got what do you call it? LabVIEW and a few other things on my computer. I've just got to configure them for it. This is already set up for GPIB. You can see set at address 22, but I've just got to set my computer up. But yeah, anyway, that's that, and I'll see you on the next video. I will be doing work on the RF amp tomorrow. In fact, if the pain keeps at the level it is now, I might even start doing some work on it tonight. So I'll definitely have a video on this tomorrow. What I'll probably start doing tonight is I'll cut this board down to size. I'm basically going to make the board. You see these little corners where the screws are. I'm basically going to make the board fit, you know, in between two sides, however big that is, and leave it as wide as it is already, if that makes sense. So I've got as much board space as I can have. Although to tell you the truth, I'll probably end up cutting it down because I want to keep it as small as it can be. who knows how small it end up being. I've been thinking about the layout, what I'm going to do, and I think what I'm going to do is obviously all the signal stuff, the controlled impedance traces on the top are going to come in pretty much like they are there on that layout. But the power rails, I think what I'll do is I'll put, because don't forget there's going to be ground plane on top and bottom stitched together around everything, control impedance traces. We've got to add the feedback network for the filter, and the power terminals. So what I think I'll do is I'll put these literally straight underneath the power pads, so that the power pads come out on the bottom of the PCB, and we'll mount the decoupling caps going to the ground plane like straight where the back of the power pins are, and then a couple of little traces that will go off to a power connector, including the ground trace. It'll be a three-way connector. I've already got everything for this. I've got a huge assortment of just random parts, and I've got yeah, the one drawer that's broken, my luck, anyway, as you can see, I've got a good assortment of those little guys, so I've got a good assortment of everything in here. Yeah, so that's all good. I've got everything that I need for it. I've just got to start doing it. So I'll have a video on that tomorrow. But yeah, that's all for tonight. Alright, everyone take care, and I'll see you on the next video. Thanks.